This is Honors Geometry, section 7.1 on ratios and proportions. And we're looking at a few proportions here. Proportions are when you have one fraction equal to another one. And the way that we can solve these is to get rid of denominators. In other words, I don't want to have the x in the denominator on the left, so I can multiply this left side by x, which will essentially eliminate it, and multiply the other side by x as well. I don't want to have 25 in the denominator on the right, so I'll multiply this side by 25. But then we have to multiply the other side by 25 as well. Essentially what we're doing then is we're taking 6 times x, and we're also taking 25 times 3. We're cross-multiplying x times 6, 25 times 3, and from here we'll divide both sides by 6, so x equals 75 over 6. And we can simplify that, divide the numerator and denominator both by 3. And we get x equals 25 over 2, which is 12.5 or 12.5. Exactly. The next one, rather than going through the process of multiplying by denominators, we're just going to straight cross multiply. So 6 times x minus 2 is equal to x minus 1 times x. I'll distribute that x and distribute the 6. Because it's a quadratic, we're going to get everything to one side. So x squared minus 7x plus 12. Moving everything to the right. This factors as x minus 3 times x minus 4. So you get solutions of x equals 3 and 4. Just with a real quick check here, I want to make sure that those denominators don't equal 0. And if I plug in 3 or 4, neither of those would become 0, so I'm confident my answers are correct. Last one here, cross multiply again. And we get this. We'll move everything to the left. X squared minus 7x minus 18 equals 0. That factors as x minus 9 times x plus 2. And then we get solutions of x equals 9 and negative 2. However, this time, if we plug negative 2 in, we do get a denominator of 0, so that one doesn't work. And our one and only solution is x equals 9. And next up, we're going to use this idea of proportions and apply it to triangles in geometry. If the ratio of 3 angles of a triangle is 4 to 5 to 9, find the smallest angle. So if the angles themselves were 4 degrees, 5 degrees, and 9 degrees, they wouldn't add up to 180 degrees. So this trial and error could get us some potential answers. Instead, we're going to go for a more direct way. We don't know what the scale factor is. Maybe we have to multiply all these angles by 2. Maybe we have to multiply them all by 3, maybe some fraction. I don't know what it is, so I'm just going to say there's some scale factor, x. So then 4x plus 5x plus 9x, that is equal to 180 degrees. If you combine all these terms, we get 18x equals 180, x equals 10. Now to solve the question, if x equals 10, then our smallest angle would be 40 degrees. The reason we're looking at the proportions is partly to solve an example like the previous one, but also we're going to get into similar polygons. And we need to make a distinction between equal, congruent, and similar. So we'd say that two polygons are similar if they have the same size. In other words, they have the same area. Two polygons are congruent if they have the same size and shape. In other words, they are identical. They're exactly the same size, exactly the same shape. They might just be in different locations. And the last thing that we have is this little tilde, this similar symbol. This just means that they have the same shape. So we might have a bigger one and a smaller one. They are going to have a scale factor. The scale factor might be 1, so maybe they are actually congruent to each other. But equal means they have the same size. Congruent means they have the same size and shape. They are identical. And then similar means they have the same shape. And that's when we're looking at the scale factors. So we can say two polygons are similar if and only if all corresponding angles are congruent. And that by itself isn't enough, because we could have a square with 4 right angles and a rectangle with 4 right angles. All the corresponding angles would be congruent there. That's not going to give us enough for similar. The other thing that we need is if all corresponding sides are in the same ratio. So if we have a rectangle that looks like this, and we have another rectangle that looks like this, so we get all the corresponding angles to be congruent. And then let's say that this is 2, 3, and 4, 6, 4, 6, 2, 3. We do have the same ratio between all the corresponding sides. 2 is to 3, just as 4 is to 6. And so that would make these two rectangles similar to each other.